Good morning, ladies and gentlemen. Welcome back. It's been a while since you've seen my face. It's Mr. Chen for another video of MCR3U, Functions 11 on the Sequences series. And I just wanted to hopefully reach out to you just to talk about where we're headed. And so let's get to the shared screen. And hopefully that's clear for you. As always, feel free to pause the video. Please refer to the Google Classroom and the notes. And today, what we're going to be talking about is our second portion of our unit. And I can kind of lump them all together. So we're going to take a look at recursive sequences, arithmetic series, and geometric series. So I think it's lesson 4 of the recursion formula. And then it seems to be out of numbering sequences. It says lesson 2 and the lesson 3 for the arithmetic and geometric series specifically. So although basically what I'm trying to get at here for a quick lesson before we go to the handout, for recursive sequence, the basic bottom line is a sequence that is generated from previous terms. And one famous one is the Fibonacci sequence that some of you might have heard of. But unlike an arithmetic and geometric sequence, which can be rewritten as a recursive sequence, a recursive sequence is kind of fundamentally given to you as some kind of relationship to the previous terms, and you can't really find, let's say, the 5th term of a recursive sequence. Let's take a look at the handout. So for question 1 of the very first page of the recursion formulas, it says if the general term of a sequence is given by Tn is equal to 3n minus 1, find the 1st term, 3rd term, and 7th term. So notice this particular question, if I wanted to find the 7th term, we can actually find that with no problem. So this is just making sure you can actually plug things in. Oops, my apologies. So let's just try to do this together. So T1 is equal to 3 times 1 minus 1, which of course is 3 minus 1, which is 2. The 1st term is actually 2. The 3rd term, we can do that here. 3 times 3 minus 1. And again, I think a lot of you know where I'm getting this, that multiplication of 3 is because it's the nth term. So 9 minus 1 is 8. And T7 is equal to 3 times 7 minus 1, which is 20. I'm just going to give you the answer. It is arithmetic because this equation looks like an equation of a straight line. Okay? So question 1 was just a warm-up to making sure you could actually plug them in. And hopefully you could, if you have to cheat by looking at the answers. So recursion formulas, notice this particular sequence, it doesn't tell us the 1st term, but it keeps on going. And again, what I think you should be able to do for this question is maybe find either the common difference or the common ratio. So let's just take a look at the common difference. 11 minus 8, that's plus 3. 14 minus 11, that's plus 3. So chances are, since it has a common difference, but let's just make sure. 11 divided by 8 is 11 eighths. And 14 divided by 11 is 14 over 11. So there's no common ratio. So the answer to this question, is the sequence arithmetic or geometric? It's arithmetic because it has a common difference. Now, just to let you know, the recursion sequences are one of the hardest ones for me. They're really neat, and it's kind of easy. Just notice the question D here. What is the common difference in the sequence? D is equal to plus 3. If we know the term is T4 of the sequence, can we find the 5th term of the sequence? Absolutely, because that would be Tn minus 1 plus 3. So just to give you a hint, for an arithmetic sequence, we can write a recursion formula as such. Oops. So a recursion formula for an arithmetic sequence is also rewritten as this. So question D is if you know the previous term of the sequence, can we find Tn in the next sequence? Yes, with common difference. So if we know any two successive terms of the sequence related to Tn equals Tn minus 1 plus 3, notice that's in. Can we determine the sequence uniquely? Yeah. So these questions are really straightforward. And let's just talk about one of the questions here. Let's take a look at the second page, question D. Notice they gave you the first term, first term is 2, and then Tn is equal to 3 times Tn minus 1, where n is greater than 1. So what I'm trying to say for you, or the whole big idea, and let's make this in blue. What we're trying to say is, if I wanted to find the third term, we couldn't find it directly. And the reason why is because the third term is saying, according to this formula, we need to do 3 times Tn minus 1, which is, of course, the second term. So we don't have the second term, right? We don't have it in this list. All we have is the first term. So this one means we have to build it up. So to find the second term, we need to do 3 times the first term, which of course is 3 times 2, which is 6. So now that we have this answer of 6, we can now proceed on to find the third term. And it's going to be 3 times that 6, which is 18. So all it really means is find a recursive formula. All right, find out the next preceding term. That's the really big idea. I actually find question 4 really tough, and some of you are probably smarter than me. There's actually many ways of solving this. There's not only one way. Even question 3 is also really good, so I think a lot of you can figure that out on your own. But question 4 is find a recursion formula for each of these sequences. And so for question 4a, it starts out with 3, then goes to 0, then goes to -3, then to -6 and -9. And to me, I actually understand this is actually an arithmetic sequence because it has a common difference of -3. And so a recursive formula could probably be the preceding term minus 3. But there's so many other ones. How about for geometric? A geometric recursion formula could probably be and this is for geometric sequence. So if we know the common ratio, we just simply multiply by the preceding term. That's all it is. So some of these questions are pretty straightforward. And again, you have some answers here. What's really neat is this appendix, but we're going to take a look at that later. Okay, so don't feel bad if you're not too sure what's going on. Hopefully that helped with the recursion sequences. So let's go back to the preceding part. So now, an arithmetic series, what we're going to show you next. And basically the definition is the summation of an arithmetic sequence. So for example, let's just say we have this simple arithmetic sequence. What could be an arithmetic series of the sequence? Well, it would be rewritten as this: 2 plus 4 plus 6 plus 8. And we're taking the sum. That's why it's called a series. So some of you might remember from your grade 9 electricity unit on series and parallel circuits. This is kind of that analogy, adding those resistors in series. So adding them up. So back to arithmetic series. So the top part here is a good review. Of an arithmetic sequence. And this is what I was trying to talk about. I may or may not have brought it up. is related to a Gauss, famous mathematician. In fact, he's one of the greatest, if not innovative mathematicians on our planet. In the arithmetic series, there's actually two formulas that you can kind of use. And I wish we had more time to talk about the proofs, but I'm just jumping up to the equations so that you can use it. So the first one is, if we, and the symbol that we use is this, capital S. S stands for sum. In university, you'll learn this symbol. This is called sigma, but you don't have to worry about that. We're never going to use this one in grade 11 or even grade 12, I don't think. But you will see it hopefully in college or university math. And I think we'll be talking about what's called finite series, where series that actually end. So the equation we're going to look at is the second one here. The first one is just it just says in words. Basically, you take the first term, take the last term, take its average, and multiply by how many terms there are. And again, as you can see, that another way of actually writing it is as Sn equals a plus Tn over 2 times n. So that is that equation. The other equation, notice we actually have the common difference in that. And to me, this one's, in my opinion, because this is how I was taught, we take the number of terms, divide by 2, so kind of like the average. And notice how the equation looks. 2a, so twice of the first term, plus n minus 1 times d. And that's why I'm trying to show you. It looks very, very similar to this equation. So this equation that I circled, as for an, oops. This equation is very similar to what you've seen, which was for an arithmetic sequence. And this one's for a series. So let's take a look at this. And again, some of you are realizing, question 3, some of you can actually probably just use your calculator and add them up, right? And the whole point is to use some algebraic skills, right? To find out some processes. So when you do this, don't get me wrong, a lot of you realize, well, I can add up 50 terms, not a big deal. But I think a lot of you understand the whole point is to use these formulas, right? So sometimes you have to use either the arithmetic sequence or the arithmetic series to find that. So to answer this question, question 3 is a really diagnostic question here. What is the first term? The first term, of course, is 1. It's this term right here. What is the common difference? I think everyone agrees the common difference is 1. And again, if you're finding it difficult, don't feel bad that if you have to write it out as an arithmetic sequence. How many terms are there? Well, because it's going up common difference by 1 intuitively, and again, this is not so obvious, the answer is 50. But let's just pretend that we are going to do it. So Tn is equal to a plus n minus 1 times d, where a is 1 plus n minus 1 times d, but we do know that that term is 50. And so when you, that's 1, my apologies. We already know that 1 minus 1 is 0, so n is equal to 50. Compute the sum. And again, some of you actually understand how to add this up. There's a couple ways of doing it. Let's use the first one here. Let's call this equation 1. Call this one equation 2. The first one is, if we know the first term, which is 1, we know the last term, which is 50, divided by 2, and times about how many there are. Take out a calculator. And the answer is 1,275. It's pretty easy, right? For question 4, notice, find the sum of 100 terms of the arithmetic series, 1 plus 4 plus 7 plus 10. And again, let's just say we didn't know they told us it was an arithmetic series, but this seems to be going up by plus 3. We don't know the last term, and we could figure that out, but let's use the formula, right? So in this case, we want to find the sum of the 100 terms, right? And I apologize, this should be set 50. So let's go back to this one. So we're going to use the n divided by 2 times 2a plus n minus 1 times d. So this becomes just formulas. 100 divided by 2 because there's 100 terms. 2 times 1, the first term is 1, plus 100 minus 1, which is 99, times the common difference, which is plus 3. Take out our calculator, do the brackets first. I think you get the answer of 14,950. Just erase that. My handwriting got horrible there. Sorry about that, ladies and gentlemen. Much better. Let's keep on going. That's the first page. Fifth question here is pretty good. 6 is pretty good. So let's just try one more of this arithmetic series. Question 7. For the arithmetic series, the first term is 2 and the 10th term is 29. So notice what they're telling us. The first term is 2 and the 10th term is 29. Find the sum of the first 10 terms of the series. Oh wait, this is too easy. I'm not gonna do this one. My apologies. I think you guys can figure this one out. There's another one that I think is interesting. Which one is it? Sorry, it's this question 14. I might not have enough room. And this will be the last one for this part. The 10th term of the arithmetic series is 34. The sum of the first 20 terms is 710, the term of the 25th term. So let's do this carefully. So they're telling us the arithmetic series. So the 10th term is 34. And the sum of the first 20 terms is 710. Find the 25th term. So that's what we got to do. So a couple ways of doing this. I think a lot of you understand. We're probably going to treat this first of all as a sequence. So 34 is equal to A plus, and again, 10 minus 1 is 9. So 9 times D. So we have one equation. And again, hopefully you know where I got the 9, because it's 10 minus 1, which is 9. And again, if you're not too sure what I'm doing, I'm using the arithmetic formula where we have the first term, A, N stands for the number of terms, 10, and D is the common difference. But we don't know anything, we only have A and D. Now the second equation, probably going to, and I think a lot of you know what I'm going to do, we have the summation of the 20 terms. So 710 is equal to 20 divided by 2 times 2 times A plus, and again, N minus 1 is 19, so 19D. And just to make sure this is cleaner, I think everyone's okay with the 71 is equal to 2A plus 19D. Now, if you didn't know how to do that, 20 divided by 2 is 10, and then divide both sides by 10, which is 710 divided by 10 is 71, and that's our two equations. Now, since I'm running out of room, I'm going to open a new document just so it makes it a little bit clearer. So I think we had was 34, I have to go back. 34 equals A plus 9D. And the second one is 71 is equal to 2A plus 19D. So some of you might remember how to do this. That's equation 1. That's equation 2. Multiply 2 times equation 1. This is not the only way, but it'd be 68 is equal to 2A plus 18D. We call this equation 3. Equation 2 is 71. We can do 2 minus 3. So subtract it that way. And basically we're eliminating the A's. 19 minus 18, that's 1D. So D is equal to 3. So the whole point of why we're trying to do this is because we need the first term. So sub in, D is equal to 3 into 1. So we got 34 is equal to A plus 9 times that 3, that common difference now, which is 27. 34 minus 27, 7. First term is 7. So what was the original question we're trying to do? Determine the 25th term. So 25th term is equal to the first term plus n minus 1 times d, 7 plus 24 times 3. Oops, didn't change. Oh well. 24 times 3 plus 7. And the 25th term of this series is 79. So I think that's enough for arithmetic series. Pretty straightforward. You can definitely work through those. And they're all pretty good. Okay, so again, this is with the patterning of a series. Our final part of our lesson today is looking at geometric series. Oops, let's go back to this one. And I think a lot of you understand this part of the lesson. A geometric series is the sum of a geometric sequence. So really quickly, just make sure we're okay. If we have the sequence 1, 2, 4, 8, 16 as a geometric sequence, the geometric series would be this one over here to the right, 1 plus 2 plus 4 plus 8 plus 16. So this is a geometric series. And again, how would you know that? You can check by checking their common ratio. Right? So let's get to the geometric series. We're almost done for tonight. Zoom in. And again, at the top here, this is just a good review of what you need to remember. So again, I actually like proving this formula, geometric series equation. And notice it's kind of weird. So it doesn't look anything really like our geometric sequence other than the a times r to the n minus 1 over r minus 1. So these questions here are really helpful. Let's just try question 2c. So we're finding the sum of the 12 terms. Notice the first term is 24, and negative 12 is the second term, and then 6 is the third term, and then negative 3 is the fourth term. Now, I think some of you are realizing I'm stressing the positives and negatives, so you have to be careful, right? So negative 12 divided by 24 is negative half. 6 divided by negative 12 is negative half. So the common ratio is negative half. So you got to be careful with that. Right? So the 12 terms, we know the first term is 24. Our common ratio is negative a half. How many terms are there? There are 12 of them, minus 1, all over negative 1 minus 1. Take out a calculator. And again, you need to make sure you remember how to do order of operations. So we have to do the brackets first. So negative a half to the 12, which of course is going to be positive, minus 1 divided by negative 1.5 times 24. And we get 15.999609, and it keeps on going. And let's just double check our answer. And there you have it. You can definitely get it as an exact answer, or you can give me a decimal answer. So just be careful with your formulas and punching it in. Let's try another question here. Let's try, I don't know, let's try this one, question 5. This is probably our last one, because I think you're getting it. In a lottery, the first prize is $1 million. Each successive prize is half the preceding prize. How much is the sixth prize? Right? So basically, if you want to figure out what's happening, first find out the geometric sequence. So the first prize is 1 million. Right? And then the next one is 500,000. The next one, 250,000. So first of all, we're finding out for question A, how much is the sixth prize? This is a geometric sequence. So to find the sixth term, the common ratio is a half. So first term is 1 million. Half to the n minus 1, but 6 minus 1, that's 5. So that's going to be 5. Let me just erase that. Let's use different colors. So this is 5. So taking our calculator out, get an answer times by 1 million. So the sixth prize is 31,250. How much money is allotted though in 7 prizes? So they want this like total money, right? So this time it's a series, right? So they want the sum of the 7 prizes. And again, the formula is, if you've forgotten, a to the Rn minus 1 over R minus 1. So 1 million is our first term. R is our half to the 7, because there's 7 prizes they want, over half minus 1. So half to the 7, which is a small number, minus 1, divided by negative half, times by a million. And I think you get 1,984,375. Again, let's check this answer. Question 5. And there you have it. So I think these are pretty straightforward. If you get stuck, don't feel bad if you have to look at some of the answers. There's some obvious neat patterning questions, like a fractal question. I do recommend you try that. They're all really good. And there's a reason why we're teaching you this with the geometric series. Okay. So one more time, just to recap really quickly as I go back to this part. We looked at recursive sequences. And again, these patterns are just based on previous patterns. Right? Again, famous one is the Fibonacci sequence. Arithmetic series is the summation of the arithmetic sequence. And a geometric series, it's summation of a, geometric series is a summation of a geometric sequence. Okay, so let's just recap, make sure we're all right. Let's just write down the formulas. Recursive sequence, notice there is no formula for that. But right now, you basically learned almost everything you need to know for this unit. So as a recap, for an arithmetic sequence, it is Tn is equal to a plus n minus 1 times d. For a geometric sequence, it is Tn is equal to the ar to the n minus 1, where we're stressing common difference and common ratio. Arithmetic series, there's 2 of them. I like this one. Or we got that one. My handwriting is horrible. And a geometric series is as follows. So there's this one, 2, 3. Notice those ones. And that's 4. So with recursive sequences, there is no formula. It's because it's based on previous terms. Hopefully this has been helpful. If you have any questions, please let me know. You're always welcome to email me if you have any problems. Thank you for watching. Have a nice day. Bye-bye.